Hello everyone, this is Aniket Gowde along with Group F10 and we are the students of Vishwakarma Institute of Technology Pune. Here we are going to explain bus architecture as a part of our computer organization and architecture syllabus, starting with the basics of bus architecture in computer organization and architecture. In the world of computer architecture, bus architecture is the backbone that enables different components to communicate effectively and efficiently. Now, what is bus architecture? A bus is a communication system that transfers data between components of a computer or between computers. A bus is a collection of wires and pathways on a circuit board that allows different components to communicate with each other. The bus architecture is the design of the bus which determines how the components communicate with each other and how data is transferred and how much data can be transferred at a time.
Hi everyone, Alok here, and I am going to talk about types of buses. So basically, there are two types of buses, external bus and the internal bus. The external data bus connects the processor to adapters, the keyboard, the mouse, the hard drive and other devices. An external data bus is also known as external data path. You can see the external data lines by looking between the expansion slots on the motherboard. Universal Serial Bus, USB, PCI bus and IEEE 1294 are common examples of external buses. Now talking about the internal bus also known as the internal data bus, memory bus, system bus or front side bus connects all the internal components of a computer such as CPU and memory to the motherboard. Internal data buses are also referred to as local buses because they are intended to connect to local devices. The internal bus is further divided into three types: data bus, address bus and control bus.
Hello, I am Jitendra. A data bus is a system within a computer or device consisting of a connector or set of wires that provide transportation for data. A data bus is a data-centric software framework for distributing and managing real-time data in intelligent distributed systems. It allows applications and devices to work together as one integrated system. A data bus can transfer data to and from the memory of a computer or into or out of the central processing unit that acts as the device engine. A data bus can also transfer information between two computers.
Inside a computer, components need to communicate with each other to perform tasks efficiently. Buses act as pathways for this communication. First, let's talk about the address bus. It carries memory addresses, helping components find the exact location in memory they need to access. The address bus consists of wires that transmit binary signals. The bus width determines the maximum memory capacity that can be addressed. Now let's move on to control bus. It carries signals that control operations within a computer. The control bus includes lines for read, write, reset and clock pulses, ensuring synchronization and proper coordination. The address bus and control bus work together. When a component needs to access memory, it places the address on the address bus and sends a control signal on the control bus. The memory until then performs the operation and sends data back through data lines. This seamless coordination ensures efficient data transfer and proper functioning of the computer system. To summarize, the address bus handles memory addresses while the control bus carries signals that coordinate operations.
The diagram illustrates the concept of bus architecture, which is fundamental design in computer system. The bus serves as a communication pathway connecting different components within the system, such as CPU, memories, and input and output devices. As we can see, they are interconnected to each other via the bus systems. In the diagram, you can see the parallel wires or traces representing the bus. These wires allow for the transfer of data and instructions between the components. By using shared bus, the need for separate dedicated connection is eliminated, simplifying the simple system design. Let's move on to the advantages of using bus architecture. The advantages of using bus architecture lies in its efficiency, scalability. It enables efficient data transfer as components can communicate directly through the bus, reducing delays and improving overall system performance. Additionally, bus architecture allows for easy expansion and upgrades as new devices can be connected to the bus without major modifications. Moreover, bus architecture is cost efficient as it eliminates the need for separate communication pathway for each component. The use of unified bus reduces the complexity and overall cost of the system. Overall, bus architecture simplifies the design process, promotes interoperability between components, and provides standardized communication interface. It is a crucial aspect of modern computer system, enabling efficient and scalable communication between various internal components.
Disadvantages of bus architecture. Now, the bus architecture can be slow due to the shared bandwidth and limited scalability. It also has a single point of failure and security risk. Looking forward towards the conclusion, a well-designed bus architecture is crucial for the efficient transfer of data and communication with a computer system. Innovative bus designs continue to push the boundaries of computer organization and architecture. Thank you.